Hello, hello. I'm Chris with the Legacy team, and today we're going to be producing part 2 of the drop leaf table leg project. Now in part 1, we actually showed the legs being turned on the turning center. Today we're going to be focusing on the actual frame components, and specifically the joinery that's necessary in order to combine all these parts together. We'll be using 2 of the workstations on the Maverick CNC system, so let's go see how it's done. To complete the framework for this drop leaf table, we needed 9 parts in total. Now all these parts have the same width and thickness. All we had to do is pay attention to the exact length of each part, so that these parts are ready to be put into the CNC machine to receive the joinery processes. Because I make enough mistakes during the woodworking processes, to keep myself organized and to reduce those mistakes, I marked the blanks according to which joint goes where. In order to complete the 20 machining processes for this frame, I needed 5 test programs and 8 finished part programs. The design and programming for this project was done in the Maverick CAD/CAM software. The main type of joinery we're going to be adding to these parts are mortises for floating tenons, but we will also be incorporating finger joints for a wooden hinge on both sides of the frame. Throughout this project demonstration, I will be using 2 different workstations, the vertical and horizontal workstation, in order to cut on different sides or faces of the parts. On the horizontal workstation, we attached a T-slot table and was able to quickly set up a clamping fixture using Legacy's low pro clamping system. This first component I'm putting into the CNC is not one of the original 9 parts for the frame, but this will become a vertical fence fixture for the hinge joint. The machining process only used 2 cutters, a 1/4-inch drill bit to drill some holes for fixture alignment, and a 1/4-inch up spiral cutter to cut out the exact size of the fixture plate. Next, we were able to apply mortises to the center of these long rails. Because we're making the mortises on the CNC, we have the ability to control the size to anything we want it to be. So I have the choice of either making my own floating tenons or simply purchasing my own floating tenons. Here I ordered some floating tenons from Amazon and was able to measure them with my calipers so that we can match the size to the mortise. The convenient thing about these low pro clamps is that it's really easy and fast to adjust the clamping fixture to accommodate for different part sizes. And to simplify the setup process, I kept the corner that's closest to us the same 0 position for every single part. I mentioned I needed 5 test programs. Well, here is how I used this test program in order to make sure these mortises are perfectly centered in the material that we had. The test program cut the same mortises, but instead of cutting over a 1/2 inch deep in our material, I only cut 0.05 inches deep. Now I have physical edges that I can measure with calipers. Using a little math, I adjusted the 0 point by only a few thousandths of an inch to ensure that these mortises are cut perfectly in the center of our part. Now we can cut the finished mortises on the same component. Even if the test cuts were slightly off, they're going to be completely hidden and filled with glue during the glue-up process anyway. And now it's as easy as switching out our components and running the exact same program, and we can apply the mortises to the exact same locations on this part. Now that we've finished all the horizontal workstation processes, we can go to the vertical workstation to get access to the ends and edges of our parts. This module is called the X-Axis Vertical Clamping Station and can be added to the Maverick E-Series at any time. This workstation is the main hero for all of the joinery. Without this, we'd have to apply the mortises using other tools and equipment. Here I'm going to take the 2 end rails that we did on our horizontal work table, and we're going to apply mortises to the ends of these same components. Because I have existing mortises on the main face of the part, I want to reduce any chances of the edge of the material breaking out during the machining process by supporting the main face with an MDF backer. Instead of setting up a stopping fence on the bottom of the part, which we can do, instead I went for setting up a stop on the top of the part. This will allow me to position the top of the part in the exact position every time, regardless of the length of the part. The 5/8 through holes that are incorporated into this vertical clamping fixture make it really easy to get parts in and out of the machine using these pin clamps. Here we're going to apply the same technique of performing a test cut and measuring it. Again, the beauty of CNC is repetition. Once you have the setup procedure correct and the cutting is exactly where you need it to be, I can repeat that process as many times as I need really, really fast. These end rails are unique in which they are not symmetrical. The mortises are only applied to one end of each part instead of both ends. Because I had just finished off components that only required mortises to be applied to one end, I figured I would bring in another batch of parts that require the exact same mortises but for only, again, one end of each part. These 4 components are the hinge rails, so one end will receive mortises while the other end will receive finger joints. Now that we completed the parts that only needed mortises on one end, I needed to bring in the rest of the parts that needed mortises on both ends. This is the 3rd batch that will receive the exact same cutting process. In total, it took about 15 seconds to cut each mortise, and so you can see that once you have the setup process complete, you can pump these out really, really fast. Okay. Now we've completed all the mortises for every single part in the frame. Let's bring back the hinge components that already received the mortises, and this time we'll work on the other ends to apply the finger joints. To produce both the mortises and the finger joints, we used the same 1/4-inch up spiral cutter. Now I have to be careful and keep myself organized because the short hinge requires a 4-pin finger joint program and the long hinge requires a 3-pin finger joint program. For the 3-pin joint, we actually created these score marks on both edges to help reduce the tear out when cutting the ends of the finger joint. So before this, I did a test cut with sample parts to find out what my allowances needed to be. In total, I gave each finger joint pocket a 7/1000th allowance, and this made it so that it became a hand press fit and not a hammer press fit. Okay, we only have one more machining process to complete, and that is drilling a hole throughout the entire width of the hinge so we can apply a dowel. In order to drill this hole exactly where it needs to be, we needed to have some guide that we can use. Well, that's what the MDF fixture was for. Here I brought out an old template making technique using painter's tape and CA glue to hold the parts in place. I was able to line the corner of the blank to the corner of the MDF. And same with the short component, line it up with the corner of the MDF on the opposite side. This ensures that the parts are positioned in the right location not only to the length, but also parallel to the guide. Now all we have to do is attach that MDF to that vertical plate. This is done by first removing the fence, and then I was able to mount the MDF directly to the vertical plate using the hole pattern that was drilled earlier. And for additional precaution, I brought back those pin clamps to hold the parts in place during the drilling process. Now, to help reduce the risk of the drill bit wandering throughout the drilling process, I came up with a few different techniques. First, I created a pilot hole, drilling 1 inch deep with our 1/4-inch up spiral cutter. Then I switched to a 1/4-inch drill bit that has 5 inches of drill length. Even with a drill this long, it didn't have the flutes going all the way up the shaft. So I had to break this up into 2 different cut depth processes. The next 2 inches are peck drilling a 1/2 inch at a time, and the last 1 inch of drilling is peck drilling a 1/4 inch at a time. Even though this drilling process turned out perfectly, I was really nervous running this program. Once drilled, I was able to remove this from our fixture plate, and repeat that entire process one more time. And there we have it, all the mortises, finger joints, drilling complete for the entire frame. In the next video, we'll show the actual assembly of the frame coming together with the table legs. I hope you enjoyed watching that video as much as I enjoyed creating it. If you're interested in learning more about a legacy CNC system and what it can do for your woodworking capabilities and business opportunities, I recommend visiting our website at legacywoodworking.com. Now, if you have any questions, you can always talk to one of our CNC experts by calling 801-491-0010. You can always leave any comments or questions right down below. Now, if you'd like to see more cutting demonstrations, just click right over there to be notified when new videos come out. Don't hesitate to like, subscribe, and check that notification box so that you can be notified. And as always, thank you for watching. And remember, Legacy solves more woodworking problems than any other CNC manufacturer in the industry.